So that concludes our section on planets, asteroids and comets. So Brad, what do you think is the most important or interesting thing we've covered?
Look, I think it has to be diversity, right? We looked at all of these planets, we looked at all of these moons, and it's so easy to just to say, oh, you know, all of the Jupiters and Saturns, they're similar, and Uranus and Neptune, they're similar, and all those moons are the same, but they're not. There's such a range of diversity based on what they're made up of, how they are, and that's an amazing part of this exploration in this course.
Especially considering that they're all made of the same stuff. So if they were made of different things, you expect them to be different, but they all came from the same protoplanetary disk, and they were all originally made of the same chemicals, and yet somehow they've ended up so very different.
And because of this diversity and difference, it actually means when we're thinking of some of these bigger questions like, is there life else out there? It's not a straightforward, yep, water, no water, yes there, no there. It's because of this range, it's a very complicated question.
That's right. So what are the big mysteries remaining about our solar system? I guess one big mystery is why Mars was so warm and wet to begin with and the sun was so cold, and that's really, nobody knows.
But what about the things that we didn't cover? Is there any kind of holes in the stuff that we explored or didn't explore in this course?
Well, the biggest hole is planets around other stars. We've only talked about planets in our own solar system, and that's all we knew about 20 years ago. Yep. But in the last 20 years, the whole field of exoplanets, of planets orbiting other stars, has become a very huge topic. Now, we don't know very much about exoplanets. All we know typically is a mass and a radius. Yep. So we certainly can't talk about geology and climate for these things. But the masses and radii that we've discovered from these things are quite surprising. For example, we've discovered many other planets have things bigger than Jupiter, but much closer in than Mercury, which does not fit with our whole snowline model.
That's right. It's things we call hot Jupiters.
And in our solar system, all the planets are in nice circular orbits. Yep. But in other solar systems, a lot of planets are in highly eccentric orbits. So there's a lot of surprises in that. However, we're not going to talk about them, however sorely tempted, because we have a whole section about exoplanets in the Astro 1001 course. So if you want to discover about planets in other solar systems and how they've destroyed all we thought we knew, then check out Astro 1001.
And now that we've explored a bit about our solar system, now we can start thinking about how we're going to explore it, and that's headed to the next session of this course on space travel.